Good day, everyone. Today's topic is about work, work, work. Is this phrase sounds familiar? I guess so. Work, 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 work. Is it me happy? Work, 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 work. Okay, just kidding. So basically, society's definition of work is something that we can acquire after we study, or perhaps after we went through a very thorough training. But what does physics tell us about work? So that's what we're going to uncover in today's session. So by definition, work is a combination of force and displacement. Now take note that this force and displacement is acting on the same direction. That means force is acted on the object and the displacement of the object due to that force should follow the direction of the force. So work is done when a force causes an object to move in the direction of the force. So the equation tells us work, which is represented by capital W, is equal to force times displacement. Yes, work is a product of force and displacement, wherein the unit of force is expressed in terms of Newton and displacement is in meters. So combining Newton and meter, we get a unit of work called joule. And this is represented by capital J. Newton meter, also known as joule, named after James Prescott Joule. The next question here is, when can we say work is done or no work is done? So there are three types of work that we are going to learn in today's session. One is called positive work. Positive work is done when the force applied and the displacement are in the same direction, just like what I mentioned a while ago. So example of this is pushing an object forward. So in this illustration, we see that the application of the applied force is directed towards the displacement of the object. So they follow the same path of direction, and thus it is called positive work. The second type is called negative work. Negative work is done when the force applied and the displacement are in opposite direction. Notice that the displacement is moving forward, but due to air friction, or sometimes, or most of the times, it could be the in contact, the friction of the wheels and the road. So this friction is in opposite direction of the force, which can cause the car to slow down. So this type of work is called negative work. And lastly, zero work or no work done. So this happens when the force applied is perpendicular to the displacement. That means the direction is moving horizontal, but the application of the force is somewhat along the vertical. So in this particular example, the waiter is carrying or holding the dish towards the customer. His movement is forward, but the same time he supports the dish so that it will be carried up through its position. So in this particular circumstance, where the force is perpendicular to the direction, then scientifically we say there is no work done. So what are these factors that affects work? Number one is force. So the formula tells you that work is equal with force times displacement. That means the greater the force would result to more work. In the same manner, displacement is also a factor. The greater the displacement, which means more work as well. However, displacement and force are inversely proportional, meaning when there is a greater force, when the force is big, that means this at constant work, when the force is big, that means displacement is low. At the same manner, at constant force, when the displacement is big, that means force applied is low. And the third one that affects work is the angle. So not at all times the applied force is applied horizontally. At times it is quite slanted. So as you push a cart or pushing an object forward, so the direction of the force is quite slanted. So the angle of the applied force can also affect the work done. So at this moment, we are now going to take a short activity that will serve as a parameter of how much we learn in today's session. So get ready of your science notebook now. So these are the questions that will sum up our discussion about work. So number one, how is work described in physics? Number two, give two examples of something that we thought as work in everyday circumstance, but not work in scientific sense. So just give me two examples. Number three, what are the types of work in physics? And the last one, why is work considered a scalar quantity? So you can pause this video until you're able to answer all these four questions. Coming up next are multiple choice type of questions. Number one, a force of 40 Newton acts on body of mass 5 kilograms. So what is the amount of work done if the total displacement is 2 meters and is in the direction of the applied force? Number two, a boy pushes a parked car with a force of 200 Newton. The car doesn't move. How much work does the boy does? Or how much work does the boy do? Number three, which one is the correct unit of work? And finally, number four, which of the following processes requires the most work? A. A person holds a 1 kilogram weight stationary with outstretched arms. B. A person lifts a 10 kilogram weight 1 meter off the floor. C. A 10 kilogram weight rests on a table. And D. A person lifts a 1 kilogram weight 1 meter off the floor. So you can always go back to the item which you're not able to answer and make sure to answer it completely. So thank you so much for listening. Once again, keep going, keep growing. King Juan Learnings. Embrace learning. Thank you.